Good evening, students, and welcome to another episode of Physics with McGregor. I'm going to do some more projectile motion problems. So this one hopefully will turn out a little bit better. I've got a slightly different setup with paper and instead of the whiteboard. So to go over everything you should have to do this as well, I've got my favorite calculator, got a backup calculator, got multiple colored pencils, a ruler for drawing, popcorn, of course, in case I get hungry, which you may want to have as well, considering I'm sure this is going to be this is going to be way more entertaining than any other thing else you might possibly be watching on a Saturday night. And what else would you have to do on a Saturday night than to watch a physics video anyway? Also over here, we're going to put some equations. And the little things that we use on projectile motion problems, such as the v of y in the final direction, or I'm sorry, v of y final being equal to the negative initial whenever you're on a level surface, v of y being equal to 0 when you're at the top of a trajectory, and how v of x does not change. Hopefully you can see this, hopefully you can hear my voice, and hopefully it all goes well. There. Let's power up some calculators. Now, I ask that you please don't laugh at my hand. I do have a bit of a scar on my hand where I ran into a burning building one time and rescued some kids from a certain death, probably. And they received a bit of a burn on my hand, so it's kind of a bit of an eyesore. I guess I'll probably never be one of those hand and foot models, but you never know. Maybe the regular model industry still has a future for me, as long as they don't zoom in on my hand. Okay, first problem I want to do is kind of a slight review one, but I'll throw a little bit of other stuff in there, so that way it's a little bit different. It's going to be on level ground. We're going to say we start off at the origin, and an object is tossed or thrown into the air, follows a trajectory, and then comes down on the ground some distance away from where it began. So we'll say that this is the origin, and then over here is an x final, and let's say we want to solve for a final position, and also we want to solve for a maximum height. I'm going to put y max for like maximum distance in the y direction. Now the final distance in the x direction, we've actually done that in class a few times, so it's kind of a bit of a review, but it's good for you, and I don't know if we did the maximum height on a level ground problem like this anyway, but it's pretty much just the same as finding the maximum height on any projectile motion problem. So if you feel like you already know how to do this and you want to fast forward to it, you don't want to watch it, that's totally fine. If you want to skip ahead about, maybe like 5 minutes or so, I'll probably be done with this problem. First thing I'm going to do is make a table, of course. Now, technically, I should actually make, for this problem, 2 tables. The reason for that is because usually I solve for time on a problem like this, and the amount of time it takes to get to this position is going to be different than the amount of time it takes to get to the y max position. So that's where I'm going to go ahead and make 2 tables. Now, if you're at home doing this on a dry erase board, well, then that's easy. You just simply erase the values that don't coincide with each of those positions, and you don't have to make a new one. Since I'm doing this on paper, I'm going to make 2 tables. X, y, distance initial, distance final, velocity initial, velocity final, acceleration, and the amount of time. Okay, I'm going to do the x column first. My initial was 0. My final distance is the thing I'm solving for. I think I got my colored pens ready. Put my question mark right there. My initial velocity. Oh, I totally forgot to give you the initial values. Let's put a little angle right here, and let's give us an initial velocity, v. What did I put over here? Let's do 25 meters per second. And let's do 40 degrees on this. I think that's different than class. I hope that's different than what we did in class anyway. Okay. So to get my initial velocity in the x direction, I've got to use v cosine theta. And to get my initial velocity in the y direction, I've got to do v sine theta. I'll just do the v cosine theta since I'm going through the x1, so 25 cosine 40. Make sure your calculator's in degrees. I see a little D up here on the top of my calculator. That means I am in degrees. 19.15. Here's for a second. I'm not going to worry about this guy right here, this final velocity, because in the x direction it doesn't change. There is no acceleration in the x direction. You could say, yes, if you're talking to somebody from a Seguros class, yes, you could put a 0 right there, and you could write the same number right here again as well. That'd be totally fine. The time is one thing I don't know. So if we're looking for this x distance, or this horizontal distance final over here, I do not have enough information in this column to give me the final position. All right, so I definitely going to need some y values here. First of all, it starts off at the origin, so the original distance is 0. The final height, or the final distance, for this part of the problem, I could put a 0 right there, since we know it's going to come down to the ground at that location. But if you've done enough of these problems, you know that you're not really going to need that little piece. The initial velocity, though, that's where I have to put in 25 sine 40. And we get 16.07. Even though my initial values were in 2 sig figs, I'm using 4 to do my to get values I'm going to use for my calculations. My final velocity in the y direction, that I can get from over here. Only on the level surface, which is what we're looking at, the final velocity in the y direction when it comes down is equal to the negative velocity initial. So I can put right here negative 16.09. The acceleration, we always know that, negative 9.81, and the amount of time, we don't know that. So the first thing I need to do is to get this time variable, because once I have it in this y column, then that means I have the same amount of time in this x column, and it looks like I can use that time to get this distance right here. Just like what we did in class, I'm going to use information in this y column to get it. I can't use equation 2 because it looks like my initial and final heights are the same. However, here's a change in velocity based on acceleration, and that change in velocity requires a certain amount of time. So it means I can use this equation 3 right here. Final velocity in the y direction is equal to the, oops, I should have put VYF, not VFY, but I think you get the idea. V of O plus AT. I'm going to put, I should solve for time first, of course. So I subtract V of Y of O to the other side. I should divide by the acceleration. I get V Y final, there I wrote it correctly that time, minus V Y O divided by the acceleration equals the amount of time. Yes, this is a review of what we did in class, but why not? What else have we got to do on a Saturday night? Plugging in numbers gives me negative 1609 minus 1609 gives you a negative 32.18. You could say, since these are equal, you could simplify this and simply say 2 times negative VYO divided by the acceleration. And that's because V final equals a negative VYO. So if I replace V of F final with a V of YO negative, then I get 2 times negative VYO divided by the acceleration. So you could do that to see if that works as well. I plugged in. I skipped the negatives on my calculator because I knew they were going to cancel out. And I get 3.28 seconds for the amount of time. So I can write it up here. Since that was one of the numbers I just got, I'm going to put it with this guy. 3.28 and 3.28. I'm going to solve for this x final distance right here using this amount of time and this velocity. Look at this equation. I already solved for the variable I need. X of f is equal to the initial plus the velocity in the x direction multiplied by the amount of time. X of f equals 0 plus 19.15 multiplied by 3.28. $62.8 meters. Oops, 62.8. Can't write. There we go. Now, of course, I want that in 2 sig figs, so I'm going to put the final distance is equal to 63 meters, with the units, of course. Just like you would do if you were, I don't know, say, taking a quiz in AP Physics 1, Monday morning, something like that. That'd be pretty neat. Okay, for the next one, finding the Y max. We've done ones like this. I don't think we did, exactly one like that where it's on level ground, but it's still the same idea. What happens to the Y velocity at the top? Yes, that's exactly right. I heard somebody say it's equal to 0. Yes, always true at the top. V of Y is equal to 0. I don't have to write that as V of OY or V of FY or anything like that. I'm sorry, V of YO or V of YF, because it's simply the Y velocity is equal to 0 at the top. Now, just to follow proper protocol, I'm going to go ahead and make another column. If you know what you're doing, probably not really 100% necessary, but if this is kind of, still freshly new for you, might be a good idea, because that way you can see quite easily the difference between the two columns. There's my distances, my velocities, my acceleration, the amount of time. This little ruler is really nice. Look how straight these lines are. That's amazing. It's beautiful. X, Y. Okay. Now some of these values are going to be the same as over here, and some of them will not. We still start off, I'm going to go through the X column first, still start off at the origin. The X distance, I don't know what the X distance is at the Y max, so I'm not going to put anything there. The initial velocity, fortunately that one's the same, 19.15. The final velocity, oh yeah, sorry, I don't know that one, I'm going to put it off, yeah. And the time is different, so I'm not going to put anything right there. Here we are, the Y distance. Initial was 0. Final is what I'm solving for. So this time I'm going to put the question mark right there. The initial is still the 16.09. And for this one, I'm not going to put that the initial or the final velocity is the same, because we're trying to find the maximum height. So what I'm going to do on this one is I'm actually going to put a 0 right there, because on this one, the Y velocity is equal to 0 at this location that I'm trying to solve for. And so that's why I'm going to put a 0 right there. Notice I didn't do that up here because I was working with this location where the final velocity is equal to the negative initial. Over here at this location, the final velocity is not equal to the negative initial, it's equal to 0. And so as you can see, that's why I made two tables, because I'm starting to get values that are different from one table to another. The acceleration, fortunately, we're still on planet Earth, so it's still negative 90.81 meters per second. And I don't know the amount of time. What's that? You think I should solve for the time first? You're absolutely right. Using that amount of time, I can figure out what the height will be at the top. Let's see, we could use the change in velocity to get the time. Yes. I can't use the distance one because I don't know the final distance, but the change in velocity, that works. And of course, this one doesn't do anything for me. What about this one right here? I don't know the height, and I don't know the change in velocity, so I can't use that equation. So we're going to go with equation 3 once again. V of y final is equal to V of y initial plus the acceleration multiplied by the time. And I'm going to solve for the amount of time. So V of y final minus V of y initial divided by the acceleration equals the amount of time. Now I'm going to plug in the numbers. V of y final is 0. The initial was 1609, so minus 16.09 divided by a negative 9.81 equals the amount of time. Yes, on my calculator, I'm typing in 16.09 divided by 9.81 because that 0 is irrelevant and those negatives go away. I get 1.64 seconds. 1.64. So I write it over here. 1.64, 1.64. Technically, I don't really need to do much with this X column over here. As you can see, it doesn't really have any effect on what my answer is going to be, this Y max. And so now that I know the amount of time, though, I can get that final height since I know an initial velocity, an acceleration, the amount of time, and an initial position. I can get that final height. Look at this. The equation's already solved for it. Y final is equal to Y initial plus V of Y O multiplied by time plus 1/2 AT squared. That's pretty neat. The final height is equal to 0 plus the velocity 1609 multiplied by the time 1.64 plus 1/2 multiplied by the acceleration negative 9.81. That negative right there is important. Multiplied by the amount of time squared 1.64. Oh, we're barely gonna run out of room. There we go. Almost ran out of room there. All right, putting this into the calculator. Yes, I didn't worry about that 0 at the beginning. And also, on this calculator, if you put in 1/2 and you don't put it in parentheses, this calculator will make a boo-boo. And so I'm putting in 0.5. .19 meters. And proper sig figs, that would be, let's see, 13. I could have written this 63 over there as well. Rock and roll. Certainly makes sense. If you have any questions, feel free to email me or whatever you need to do. Okay. What? No, it's not time to go home. No, you're home. Somebody seems to think it's time to go home. Okay. Next problem. Oh, geez. 17 minutes? That problem took 17 minutes. Holy moly. Who's going to spend 17 minutes doing a homework problem? Let's skip to the most difficult one. Okay. Hopefully, you didn't skip to 5 minutes and you instead skipped to like 17 and a half or 18 minutes. Gosh, that was a long problem. I can't believe I just spent 17 minutes doing that one problem. Geez. 17 minutes of my life I'm not going to get back probably. Let's do a problem that's a little bit more rigorous. For this one, it's going to be different than something we did in class. In class, we always had either a projectile on level ground or we had a projectile coming off of a cliff and then going onto the ground, falling down a distance or going up in the air and then falling down a distance. This one is going to be different. We're going to start off on the ground right here. Projectile is going to go up into the air and then up onto a cliff and then land on the cliff. I'm going to say this is an angle theta and a velocity vector. And I just realized that I did not work through this problem ahead of time, which means there could be a boo-boo, a serious one, in fact, because think about this. Well, first of all, I should tell you what it is you're going to solve for on this. We want to know from the edge of the cliff over that x distance, where is this object going to land? That's a pretty neat question, but there's some problems with that. What if the projectile, based on the angle, what if it bounces off the cliff and goes up, off like that? So then it wouldn't even land up there. Or, even worse scenario, what if the projectile goes up without enough velocity and then comes down right there or before the cliff? That's also going to be a problem. So I really should have worked through this to make sure that it was going to work. But a few quick calculations. Let's see here. 30 sine. Oops. You know what I could do? I just had a great idea, a really, really good idea. Let's say that this is the school. And so let's say that the school, well, not the school, let's say a bigger building than that. The school wasn't very tall, or the school is kind of small. Let's say this is about half a football field, 50 meters tall. And let's see, in order to get that up onto the school, I know that a potato launcher doing approximately 36 meters per second is going to go up at least 50 meters. So to be on the safe side, let's say our initial velocity is 70 meters per second. And let's say the angle, to make sure this works, we need enough trajectory to go this distance. So let's say we've got a 65-degree angle. And let's say we're not too far away from the edge of this building or cliff, whatever it is. So we'll say we're only about this distance right here. 25 meters. That should definitely end up on top of this building. Just thinking about the dynamics of this problem, pretty much for sure it's going to end up on top of this building and not bounce off the wall or come short of the building. Okay. This problem's a little interesting, but I just want to know this distance right here. Can I do this with just one table? Well, think about the things I need to solve for without even looking at the table. I need to know how long this projectile is going to be in the air and then come down to this point. I can do that if I know the velocity vector and the angle. I can get the velocity in the y direction, which means I can use a quadratic formula to find the amount of time to do that. Once I know the amount of time, I can use an x direction, basically a distance equation, to figure out exactly how far in this direction it's going to go. That equation doesn't care whether it's up on top of a building, down below a building, or on level ground. That equation will tell me how far in the x direction it goes based on amount of time. So yes, I can do this problem using one single table. Feel free to pause the video right now and try to do this problem completely on your own without seeing what I'm going to do. That would be pretty neat. It would be kind of like, oh, I don't know, doing a homework problem where you do the problem and then you look up the answer in the back of the book. There's my x and y values. I'm sorry, x and y columns. There's all the different things we can have. Distance initial, distance final, velocity initial, velocity final, acceleration, and the amount of time. What a beautiful table. Too bad I don't have a straight edge to draw lines like that on the board. It just doesn't quite work with a root meter stick and dry erase markers. Okay, let's put in some initial values here. We're still going to call this our zero distance initially. So our x distance initially still starts off at 0, down there to the left at 0. The final distance in the x direction, we don't know that. And that's also the thing we're solving for. Our velocity initial, that's not too difficult to get. Here's our initial velocity and our angle, 65 degrees. So 70 cosine 65, come on, 29.58. Velocity final, that's obviously the same, doesn't change. I'm going to put a line right there. The acceleration, there is none. The amount of time, we don't know that. Okay. Now the y distance. We're still, just like a problem where it goes up from the cliff and then goes down to 0. Well, in this one, it's just the backwards of that. So this is still considered your 0 position. down here on the ground. Y initial was 0. The final, we know it's going to end up on top of this structure, whatever it is, 50 meters. That's a 50. There we go. And the velocity initial, we can get that with just a few elementary calculations. 70 sine 65, 63.44. Velocity final, we don't know what that is. And we might not need to know what it is anyway. The acceleration, negative 9.81. Okay. This is very, very similar. In fact, it's almost exactly like the problem where an object comes off of a cliff and then goes down to the ground, because it's going up into the air and then coming down and then continuing downward past the edge of the cliff to the ground level. We have an initial velocity, we have a initial and final distance in the y direction, and an acceleration. What that means is, yes, this is a quadratic formula problem. Oh boy, quadratic formula. So we did this in class. We know that t is equal to, well, here, I'll write it out just so, in case anybody was absent on Friday and they're like, I have absolutely no idea what this teacher is saying. Nothing he says makes any sense. If in case you're feeling like that right now, I'm going to write out the equation that I'm referring to. Final distance in the y direction is equal to the initial plus the initial velocity multiplied by time plus 1/2 multiplied by the acceleration multiplied by the amount of time squared. Okay, since I have a value for each of these, except I've got 1 0 right over here, which is, oh no, actually this time we've got the 0 right there. Ooh, it's a little different. I need to first make sure that we have a 0 on this end before I can use a quadratic formula on it. But what that means is t is equal to negative b plus or minus the square root of b squared minus 4ac all divided by 2a. Most of you, I'm sure, remember that. It's totally okay if you don't remember that. Just look it up in your old Algebra 2 book. Actually, Algebra 1 book, I think it is. Unless you actually use the same book for Algebra 1 and Algebra 2. I can't remember anymore. Who knows? All right. So time is equal to, first I need to make sure there's a 0 over here. Since the y final actually has a value this time, it didn't when it was starting off on a cliff and then coming down. So since this actually has a value, I've got to subtract it over to this side. So that means 0 equals y initial minus y final. That is your c value in the quadratic formula. Quadratic formula. Plus, here's your b value, v of y initial. That's your b value, plus 1/2 acceleration multiplied by time squared. Here's what I'll do. I'm going to, just to clarify, c, b, a. So when we go through and put our values into the quadratic formula, here's negative b plus or minus b squared minus 4 times a times c all divided by 2 times a. That's pretty neat. Okay. T equals. I'm not going to put it with the VY, VOs and all that. I did that in class. I'm just going to go ahead and put in values. V of y initial, 63.44. So negative 63.44 plus or minus square root of b squared, 63.44 squared, minus 4 times a, 1/2 acceleration. Oops, by the way, that 1/2 is negative 9 point, or that acceleration is negative 9.81. So make sure you realize this is being multiplied. That's 1/2 times negative 9.81. Don't get mixed up right there. Multiplied by the value for c, which is initial minus final. Now we can put in something a little easier. Initial was 0, final was 50. 0 minus 50 is a negative 50. Uh-oh. Oh boy. Okay, now that could give us a little problem. That's going to be a 4 times a negative is a positive. He's going to have a value minus a value here that's positive. If anything inside of this equation or this square root ever gives you a negative value, you've done something wrong. If you're working on a projectile motion problem, you should not get an imaginary answer for the amount of time unless the problem is impossible. Right. All divided by 2a, so 2 times a is 1/2 times negative 9.81. I'll write it kind of similar to that. Imagine this dot is a big multiplication. That'll make sense. Alright, I can do some simplifying. That goes away. 2 times 1/2 is gone. 4 times 1/2 right here. I can cross that out and just put a 2 right there. That's pretty neat. Alright, now that I've done some simplifying, I'm going to go through and do some math magic. Last time, the subtraction right here is the one that gave us the correct answer, and I'm pretty sure it will be the same way because of this negative number right here and that negative number. We're probably going to want the negatives to go away, so this negative would cancel out that subtraction and make it a positive. That doesn't mean put it in your calculator as positive. That just means that that subtraction is probably going to be the one that gives us the correct answer. The other one will probably give us a negative answer for time. What would that mean? Actually, they might both be positive. I don't know. I haven't done where these are wrong. Alright. This won't take very long to put in the calculator. Negative 63 minus square root parentheses. How many sets of parentheses will I need in there? I think I can do that whole thing in one. Yeah, it looks like it. 63.44 squared. Simplify your negatives. Those two become positive. So I'm going to put minus 2 times 9.81 times the 50. I just simply said that negative and that negative go away, so I'm not worrying about them. Enter. And then I'm going to get an answer for this top row. Ooh, a negative number. That's awesome. Now divide that by negative 9.81. Divided by negative 9.81. There's a positive number right there. T equals 12.09 seconds. I'll go and do the positive or the addition version of this and see if we get something that might make a little more make more sense or less sense. 63.44. Oops, I gotta make that negative. Negative 63.44 plus square root parentheses, same thing, 63.44 squared. Once again, minus 2 times 9.81 times 50 parentheses equals divided by a negative 9.81. We get a positive value. .8431. Okay, for you guys sitting at home, which of those two numbers do you think is the correct answer? I'll give you a clue. It's going to take a little bit of time to go up here. A decent amount. That's a pretty high velocity. It's probably going to go way up off the paper and then come down. It has to be the 12.09. Anybody want to guess what this 0.8431 refers to? Well, if you really like graphing parabolas, what this 0.8431 refers to is if this was a parabola and you had a x-axis going across here, it says that it will take 0.8431 seconds for the projectile to reach this point, and then 12.09 seconds for the projectile to come back down to the same point. And that's because this difference in the y direction is referring to this location and this location. That's why we get two positive numbers. However, only one of them can be correct. And the way I know which one's correct is because I know in this situation, it's going to be the bigger one. It's going to take a long time for an object to go all the way up onto here. It's not going to take 0.8431 seconds. And also I know that it's got to be the bigger one because I know mathematically here's what the 0.8431 seconds time refers to. This is going to take longer to get to right here, so that must be the 12.09 seconds. Make sense? I hope so. I really hope so. Not necessarily on your CCHS projectile motion test, but certainly a possible question on a AP physics exam test. Oh boy. Okay, now we know the amount of time, we can figure out a distance. I'm going to use the equation for distance in the horizontal direction. X final is oh, I'm sorry, I didn't write the time in here. I'm using the 12.09 because I'm solving for this location. This table refers to this location. That's why I'm putting the 12.09 right here. 12.09 seconds, 12.09 seconds. All right. X final is equal to x initial plus velocity in the x direction multiplied by time. All right. My initial was 0. Oh, no, my goodness. Why did I write that? I'm sorry. I'm solving for the final. Final is equal to initial. Is the initial 25 or is it 0? I heard somebody say 0. You're absolutely right. I heard another person say it's not the 25 because that's just simply a distance from here to the edge. Even though we are solving for this distance right here, we're just going to subtract the 25 away from it. Yes, I heard somebody say that you could put the 25 in there as your initial if you're looking for that. And that would be fine. If you want to put the 25 in there as your initial so that your answer just gives you this distance, that would be okay. I'm going to not do that because I'm a rebel. And then I'll show you how it would be just fine if you did do that. All right, our velocity in the x direction, the 29.58 multiplied by the amount of time. Here we are, 12.09 seconds. 12.09 seconds. If we get an answer that is not greater than 25, then we're going to be in big trouble. Well, not big trouble. It just means that the object didn't make it up onto the cliff. 29.58 time multiplied by 12.09 seconds. 357.6 meters. 357.6 meters. Now, that's the distance to go from here all the way over to here. So I need to subtract 25. So 357.6 minus 25 equals 332.6. I heard somebody say just now, if you put the 25 right here, you'd get this answer. And you are correct, I think. I'm thinking the video didn't just have a boo-boo. No, I'm thinking. No, that is not correct. No, you cannot put that 25 right there. No, you can't. No, you just have to remember you're going to have that you will subtract the 25 at the end to get this distance right here. Your initial has to start off at this 0. You could say that this is your beginning, which would actually be a negative 25 from, meaning the origin is negative 25. But I wouldn't do that. I would just simply say subtract 25 from your answer to get your final distance. So 332.6 is this distance right here. Does that make sense? Okay, good. Okay. Gosh, this video is now 40 minutes long, and that's ridiculous. I really want to do one more. Maybe I'll load a video on Sunday. Oh, here, I'll leave this work right here. Maybe I'll load a video Sunday. I don't know. Make sure you're working on getting the potato launcher equation. If you don't have it yet, you should be trying to do that. On Monday, we're going to have a quiz, and hopefully I can give you some more stuff on Monday. I hope this has made at least some sense. All of the problems can be done something like this. Ooh, I did think of one other thing I could do. One other thing. Well, Saturday night, you probably don't want one more thing. Oh, what the heck. I'll try to go through it quickly. Let's say it's a level ground problem. Starting off at 0. Going into the air and landing an X final distance away. And let's say that we have, what would you like to solve for? I want to have a situation where you actually solve for one of the initial values. V equals, theta equals. Do you want to solve for theta or do you want to solve for the velocity? Initial, not final, initial. Can't make it both. you'd have two equations and you'd have two unknowns, possibly one equation. We could solve for both if you had more than just a distance. I heard somebody say they wanted to solve for the velocity because it looks easier. You're right, it is actually easier to solve for that velocity. Okay, so let's say that theta is a angle of 45. I'm sorry, I don't want to use 45 because it's too easy. You'll see why maybe someday in your life, or maybe I'll have time to show you in class why 45 is too easy. So let's make it 65. Okay. Theta is 65 degrees, and let's say their final distance is right at one football field, 100 meters, except the football field is yards, my bad. Okay. X final is 100 meters, our theta is 65 degrees, and we want to know what was the initial velocity. All right, I'm going to make a chart here. This actually might require two equations and two unknowns. Actually, yes, it does. Well, it'll be fun. D of O, D final. Oops, velocity, not D. V of O, V final, acceleration, and time. This is going to be a fun problem. Our x initial was 0. Our x final is 100. Our initial velocity is unknown. Our final is irrelevant. Our acceleration, there is none, or 0. And the amount of time is unknown. In the y direction, the initial is 0. The final, that's also 0 technically when we go all the way here to this location. The initial velocity is unknown. The final velocity is unknown, but we do know that those are equal. The acceleration is a negative 9.81 meters per second, and the time is unknown. Okay. There's not much information here, and so because of that, we're going to need two equations and two unknowns. You've done this in Algebra 1 or maybe Algebra 2. I forget which one you learned this in. I'm going to set up an equation for the distance in the x direction. X final is equal to x of O plus v of x multiplied by the amount of time. For v of x, I'm going to put the equation for v of x, which is kind of on this little equation sheet right here. Hopefully you can see it. V of x is equal to v cosine theta, and I'm going to put in some other values. Just this one. This one is 0. X final is equal to v cosine theta multiplied by the amount of time. This is going to look like a potato launcher problem. Now I need an equation in the y direction. I'm going to use the one for velocity in the y direction because it's an easier equation to use. Much, much easier. We know that the velocity final, I keep writing v of fy instead of vyf. V of yf is equal to negative v of y initial. And we know that v of yf equals v of y initial plus acceleration multiplied by time. Since this is equal to this one initial, I can replace it with a negative v of y initial equals v of y initial plus acceleration multiplied by time. And I'm going to solve this for the amount of time as well. Subtracting this over to the other side gives me negative 2 vy initial divided by the acceleration equals the amount of time. So this says that the amount of time is equal to a negative 2 multiplied by the initial velocity in the y direction divided by a negative 9.81. I can solve this one for time as well. Watch this magic. X final divided by v cosine theta is equal to the amount of time. Look at that! Aren't these amount of times the same? The amount of time it takes to go from this location over to this location is also the amount of time it takes for this velocity to finally go up and then accelerate back downward and be equal to the initial velocity again, based on a certain amount of acceleration. You know what that means? That's exactly right. These two equations, there we go. These two equations are equal to each other because they're equal to the same thing. Oh my goodness. X final divided by V cosine theta is equal to negative 2 multiplied by V. Watch this magic here. Okay, yeah, I'm running out of, well, no, I was about to do two steps at the same time, but I feel like some people at home would just give up and throw their computer across the room if I did that. So, negative 2 V of YO divided by the acceleration. Okay, now, one other thing I could do, V of Y of O, I can't do anything with this where if I have two unknowns. I can only have one unknown in this equation. So I'm going to change V of YO to V sine theta because of, I just simply, just like all you guys sitting at home, you know that V of Y equals V sine theta, just the same as V of X equals V cosine theta. So I'm running out of room, so I'm going to keep writing up here this equation, but I'm going to make this substitution right there. Okay? There we go. X distance final divided by V cosine theta is equal to negative 2 multiplied by, instead of V of YO, I'm going to write V sine theta divided by the acceleration. Look at that. One equation and only one unknown, this velocity. We know what theta is. We know what the acceleration is. We know what the distance is. This is going to be awesome. Did somebody at home just say you should cross multiply? That's a good idea. Yes, cross multiplying would work here. A, A multiplied by X final is equal to, this is going to look slightly similar to equation 4, but it is not equation 4. Negative 2 V squared cosine theta, sine theta, cosine theta, sine theta. Just took this one right here, multiplied by this one. I'm solving for the velocity, so acceleration multiplied by the x final distance divided by a negative 2 divided by cosine theta divided by sine theta. Negative 2 cosine theta, sine theta. Hey, is anybody at home sitting there with a trig book saying to themselves, negative 2 cosine theta, or actually not negative, I'm sorry, 2 cosine theta sine theta, that's actually sine 2 theta. And you're absolutely right. But I'm not going to get all crazy trigonometric on you. I'm just going to leave it as the way it is because I think it looks, I don't know, maybe more, it's probably simpler the other way, but not everybody at home would remember that identity, and so I'm just going to leave it like this. One last thing, we need to take the square root of that velocity. So, square root of all of this gives you the velocity. I'm going to write it one more time, but I'm running out of room, so I'm going to write it one more time with the numbers. Square root, A is negative 9.81, X final is 100, that's easy. Negative 2, cosine of 65 degrees, sine 65 degrees. I know what you guys are thinking. You're thinking, wait, did I sign up for a physics class or did I sign up for a trig class? Well, you signed up for a physics class that's going to implement all that trig you learned, hopefully. Okay. Now, we can plug this into a calculator. Oh boy, that's a lot of things on the top and bottom of a fraction inside of a square root. Now, for you folks sitting at home with your TI-84 Silver Edition, this is not very difficult. For the rest of us with our two-line scientific calculators, it's a little bit more of a challenge, but who doesn't want a challenge on a Saturday night doing physics homework? Square root. So I'll start off with the square root, and I'm going to put two sets of parentheses, parentheses. One set of parentheses for the top, one set for the bottom. So negative 9.81, I'll put in the negatives too. 9.81 times 100. Parentheses divided by parentheses negative 2 times the cosine of 65 multiplied by the sine of 65, parentheses, parentheses. I hope this doesn't give me an error. Boom! Look at that. 35.785, whatever. I'm just simply going to say V equals 2 sig figs, 36 meters per second. And if you're thinking, I'm not for sure if that's the correct answer. Well, you have the velocity and an angle. Just go through and do a little bit of work. Solve for the amount of time it'll take for this velocity to, in the y direction, change. Get your. I'm sorry, I'm stuttering. Use this velocity to get a velocity vector in the y direction or a component in the y direction. Solve for the amount of time it takes for it to go have that velocity to get in the negative or a negative velocity. Basically, solve the amount of time that you would have over here, and then see if you get that distance over there as well. And using this number, if that all works out, then that means we have the correct velocity. Well, I can go ahead and tell you, yeah, this is the correct velocity. It is 36 meters per second. Rock and roll. This is really similar to the Spud launcher. Remember, your goal or your assignment was to get an equation based on distance and angle that gives you velocity. I've said too much. Okay, you guys, it's like almost been an hour. Seriously, this video is going to be like 12 gigabytes of data. Like, I don't think any of the videos I've downloaded off my pirate website for movies have ever been 12 gigabytes, except for that one time when I downloaded all three of the Godfather series. I think that was like 9 gigabytes. But, I mean, I paid for it, of course. Okay, time to get out of here. End this video. Rock and roll. Have a good night. I'll see you Monday.